Zeolites are naturally occurring clay that originate from a process of alteration of volcanic glass. They're composed of aluminosilicate materials that contain pores and have suitable properties for ion exchange and absorption. Ion exchange is reversible interchange between an insoluble solid and solution with the same charge. So this is what is used in water softening and purification processes. Absorption is adhering or binding atoms, ions, or molecules. Zeolites are composed of large channels and cages containing water molecules and cations, which are positively charged ions such as potassium, sodium, calcium, and magnesium that can ionically exchange with other elements. The structure can be modified by acids, bases, or salt reagents to increase heavy metal removal efficiency. Zeolites are found all over the world, and the properties are unique in each region, with the most common areas being in Slovakia, Greece, US, Bulgaria, and Italy. This is important because not all products are going to be the same or work the same. Cliniptololite is the most applied natural zeolite for removal of heavy metals. So when we use the term zeolite, that can refer to any of the mineral species, not just cliniptololite. So you want to make sure if you're getting a zeolite product that it's ZC or cliniptololite, only because some mineral species such as aragonite can be carcinogenic. This study shows that cationic exchange selectivity of various zeolites, with cliniptololite being most selective for lead, copper, zinc, and nickel. Zeolite cliniptololite, or ZC, has shown multiple positive effects that include detoxifying as an antioxidant and anti-inflammatory benefits. Modification of ZC through micronization, which we'll see as PMA-ZC, improves its benefits in preclinical and clinical models. So studies show that PMA-ZC improves physical chemical properties, that micronization accentuates detoxifying characteristics. ZC can function as an antioxidant by capturing free radicals and reducing the formation of reactive oxygen species. So some studies we have are that in lead-poisoned mice, modified ZC reduced the accumulation of lead in the intestine by more than 70%, with protective effects on brain tissue. Rats that were intoxicated with organophosphates showed to be effective at restoring cholinesterase activity. It has been recognized for ZC to have clear evidence on improving physical fitness and efficiency of farm animals by removing numerous harmful substances, including ammonia, nitrates, mycotoxins, and other toxins. Cattle integration of ZC in feed has reduced nitrates and concentration of alpha toxins, which are toxins produced by fungi in their milk, and improving systemic toxic effects. ZC has shown a positive effect in chickens by balancing total intestinal microbial flora, reducing toxic effects of alpha toxins, and increasing antioxidant activity, peroxide catalase, and superoxide dismutase, and increasing levels of omega-3 fatty acids in eggs. So there are limited studies in humans, but there are some showing no alterations of hydrosaline equilibrium in human athletes, and no toxic effects have been shown in studies. But I'll talk about one of the oncology studies in the next video. This study looked at the effect of PMA-ZC, or Panaceo Microactivated Cliniptololite Zeolite, in reducing the incidence of chemotherapy-induced peripheral neuropathy, as well as hematological and liver toxicity. So they looked at ZC because of its detoxification properties, as ammonium is recognized as a neurotoxic agent produced by tumors, and the positive impact ZC may have on immunity and oxidative stress. So cytotoxic chemo agents such as alkaloids, taxanes, and platinum derivatives are frequently cause of neurotoxic symptoms such as peripheral neuropathy. This study included 120 patients, predominantly with colorectal cancer, that required oxaliplatinum-based chemo, and they received either PMA-ZC or placebo while undergoing chemo. There was neuroconduction studies that were done at baseline, 3 and 6 months post-chemo. So patients that were treated with PMA-ZC were able to undergo more cycles of chemo, which was a significant improvement in tolerance to therapy. And then the group treated with PMA-ZC, they didn't show a significant lowering of chemo-induced peripheral neuropathy, but it was statistically significant in men. So the lower chemo-induced peripheral neuropathy in men was also accompanied by lower instances of severe grade hematological toxicities. It also referenced a preclinical efficacy study where ZC lowered total lipid count and LDL in patients with lipidemia or dyslipidemia. So I find this study very interesting because of the potential therapeutic and benefit of ZC for other disease states, such as in oncology and dyslipidemia. So I would expect there to be more human studies to come.